Hello and welcome to this clip going through the ABG paper for Friday 26th of May 2017. The questions from this paper that have been requested by my class are 2, 3 and 4, so we're going to go through those ones. So looking at question 2, it obviously starts off by talking about the fact simple molecules are what the question is about, and it starts introducing pairs of electrons in molecules can be described as bonded pairs or lone pairs. And in the first part it says show the numbers of bonded pairs and lone pairs around the central metal, or the central atom, in each molecule. Now if you're not sure about how to visualize this, you might want to consider, in the extra space that's provided in the exam, drawing a dot-cross diagram. So I'll do NCl3 as an example. So the first thing to do is to identify the central atom. Central atom is nitrogen, obviously. Now we have to put the electrons in. I would only do outer shell electrons at this point. So if we look at the example we've got there, you can see quite clearly that around the central nitrogen atom you have 3 bonded pairs and 1 lone pair. So by doing the same thing for the other molecules, you can work out what the number of bonded pairs or lone pairs would be for them. Now all that's really happening is that similar molecules or analogous molecules to ones you'll have seen in textbooks are being used here. So NH3, CH4, BF3 and H2O are all analogous to the 4 molecules given. So you can use the number of bonded pairs and lone pairs from your flashcards for those particular molecules here. All you have to do is recognize that each one has a sort of similar example from your textbook and your notes that you can remember. So now that we're getting into it, hopefully you can start to see that the next part is simply applying these ideas to the shape, the expected bond angle, and whether it's polar or not. Okay, so that allows you to work out the shape and the expected bond angle for each one. So to work out whether they're polar or not, you need to look at whether they're symmetrical or not. So the symmetrical ones will be non-polar, and in the polar molecules, the dipoles won't cancel. So that's how you can remember each one. So moving down to the next question, they want you to draw a diagram to show the strongest type of intermolecular bonding between 2 molecules of ammonia. So looking at the instructions, you need to include the relevant dipoles and lone pairs, and you need to label the bonding between the 2 molecules. So if you start with one molecule, you can plan where you're going to put the next one. So making sure that your hydrogen bond is labelled, you've got all your dipoles in, all your lone pairs, and you've orientated the molecules so you can draw a straight dotted line from the lone pair of 1 nitrogen to the hydrogen on the adjacent ammonia molecule. That should cover you. So moving on to part C now. It says BCl3 gas reacts with water to form a solution containing 2 acidic products. So whenever they give you a piece of information like this, always have a think about it because it might be useful later on. Now the empirical formula of the compound A is going to be quite straightforward. So doing the 2 steps of percentage by relative atomic mass and then dividing by the smallest should lead you to BO3H3. So this final part is an application question, and like I said a while back, the information at the beginning of the question will be useful later on. So I've highlighted the 2 pieces of information that you need to do your equation. Now the fact that the command word says suggest, it doesn't mean you have to know this, it just means use the information that they've given you to see if you can work it out. So if we put in what we know already, BCl3 reacts with water to make BO3H3, and I'm putting in HCl because another acidic product containing chlorine would obviously be HCl. Now if you look closely, you'll see that there's 3 chlorines in BCl3, So you need 3 HCl's, and now to balance out all the hydrogens, because you've got 6 on the right-hand side, you need to put 3 H2O's on the left-hand side. So that now takes us to the end of question number 2. We're now moving on to question number 3. So looking at this next question, the first part, part A, asks you to fill out the table. So this should be simple recall. So it's either simple recall of giant structures or simple molecular ones. So let's put these in. This should be straight recall now. So the next one is about properties. So this should be fairly straightforward as well to tick off. So we're only really looking at the metals being ticked off at this point. So now let's move the page down, and it says the melting point of a substance is dependent upon the forces between particles, and it asks you to name the forces in the particles and the structures of chlorine and silicon, and explain why chlorine has a much lower melting point than silicon. So if I move the page down a bit further, we can see there's actually 4 marks on offer. Now, one possible way of doing the answer would be to do it like a table, rather than having to do lots and lots of sentences. You could do it bullet point wise as well, obviously, but I'm just thinking about ways in which you can minimize the amount of writing you're having to do. So it's important to be quite specific about how you describe the forces. Just saying London forces, for example, wouldn't be enough. You have to say that it's between molecules, and likewise for your silicon, it's covalent bonds between the atoms. So in this case, you could either say London forces are weaker than covalent bonds, or under silicon you could say the opposite, the covalent bonds are stronger than London forces. So for melting points, you need to do it in terms of energy needed to overcome forces or bonds. So less energy needed to overcome London forces, or more energy needed to overcome many strong covalent bonds needs to be put next to the appropriate element. So in this next part of the question, again, the highlighted part shows the instructions that you need to follow. So they want you to do a label diagram to show the metallic bonding of magnesium. So the first thing to do is to put in at least 2 rows of labeled cations. And the second thing to put in is your labeled delocalized electrons. You don't necessarily have to have precisely 2 electrons for every Mg2+, or precisely 3 electrons for every Al3+, if it was aluminium they wanted you to draw. But just show them kind of randomly spaced around and point to a couple and say delocalized electrons. That should cover you. And just to be on the safe side, you may wish to label them magnesium ions too. So let's now move the page down a bit. And the next part wants you to explain why the melting point of magnesium is higher than that of sodium. And in the answer, you've got to refer to the particles and the forces acting between them. So I'm not highlighting the instructions here, because I think you probably are getting the picture of how to follow them and making sure you read the question before you start. So the things to talk about here are outer electrons, cation charge, and the relative sizes of the electrostatic attractions. So a simple comparison of the number of outer electrons, naming each metal as you go, and giving the number of outer electrons would be appropriate. Something similar for the cation charge. And the attraction between delocalized electrons in the lattice and Mg2+ is greater than the equivalent attraction between delocalized electrons and sodium+. So the next part of the question asks you to explain what periodicity is. So something equivalent to what I've written there, a repeating pattern of some kind of properties across a period. So let's move on to the final part of the question, or the final part of the clip. This is question number 4, and it's about group 2 elements and their compounds. So this calculation requires you to identify metal M. So as always, we're going to use the data moles, equation moles answer technique here. So if we look through the data that we're given, we need to find something for which we can work out the number of moles. So obviously we've got the number of moles of hydroxide ions because we've got the concentration and we've got the actual mass of the group 2 element. And we also have the volume. So that allows us to work out what the number of moles of hydroxide are. So that gives us 2.624 times 10 to the minus 3. So the equation shows us clearly that the number of moles of hydroxide to the number of moles of the metal is 2 to 1. So that gives us 1.312 times 10 to the minus 3. So now we want the molar mass of M. So we do this by working out the mass over moles. So that gives us 87.7 grams per mole to the minus 1 to 1 decimal place. And using the periodic table, we can work out that M is strontium. Okay, so we now need to move the page down a bit to look at part B. So, obviously, when I was just doing the answer there, I didn't realise that there was a space for them. So let's now just put them in to make sure. So it's always a good idea to actually use the answer space provided. So, looking at the lower part of the question, part B, student bubbles chlorine gas through an aqueous solution of magnesium iodide. This again is recall of reactivity trends from first year. But the important thing is to look at what the student would see. So, although you might work out that you'd have iodine produced, if you put that, that doesn't give you a correct mark. So you need to say that the solution would turn brown. And they obviously also ask you for an ionic equation. So in terms of the answer to part I, say what the solution was to start with, colourless, and what it becomes, which is brown, so the actual change. In the bottom part, part II, magnesium doesn't need to be included here because magnesium is a spectator ion. So let's now go on to the final part of the question. So this bit is almost all recall of group 2 chemistry as we can apply it to barium and its compounds. So obviously when you heat a metal in air, it's likely to react with the oxygen in the air. So A is obviously going to be barium oxide. Now you're told that barium oxide reacts with water to make barium hydroxide. Now hydroxide is an alkali. So when an alkali reacts with an acid, it's going to make a solution of a salt. And in this case the acid is HCl, so it should be BaCl2. Now barium chloride is going to react with silver nitrate because it contains the chloride ion. So the precipitate that you'd expect would be AgCl. Now the bit that's a bit more challenging is the reaction of barium hydroxide with carbon dioxide. Carbon dioxide is a weakly acidic gas. So again, it's an acid-base reaction. So the precipitate that you're going to get this time is a carbonate. Now this was a bit deductive, but the fact that it was carbon dioxide shouldn't be too difficult to lead you in the direction of a carbonate being produced. So I'm moving the page down. It says, suggest the formula of the other substance formed when AgNO3 aqueous is added to solution B, or barium chloride. So all you have to do here is think about the ions that have been used to make the precipitate. So Ag plus and Cl minus have been used to make the precipitate D. So therefore, all that you have left is barium 2 plus and nitrate. Now be careful here because they want the formula. So don't give the name. As soon as you've worked out it's barium nitrate, don't just write down barium nitrate. Actually put the formula down because they've told you to suggest the formula. So this next part, part D, is the final part of the question, I believe. So let's have a look. We are asked to define the term first ionization energy. So because it's 3 marks, you've got to be quite specific. So it's the energy needed to remove 1 electron from each atom in 1 mole of gaseous atoms. And then it asks you to write an equation including state symbols for the second ionization energy of strontium. And I can't stress enough here how important it is to actually put the state symbols in. I've literally just finished marking 60 mock exams, and the number of people who forgot to put state symbols in was quite interesting. So please remember to do this. If you're told to put state symbols, put them in. So because it's the removal of 1 electron, like you did in your definition a minute ago, you need to make sure you're actually taking away 1 electron, not 2, even though it says the second ionization energy. So you've got to start with Sr plus in gaseous form, going to Sr2 plus in gaseous form, and removing 1 electron. So now let's go down to part III. So to do that, I need to move the page down a little bit again. So let's have a look. This is 6 marks. So a chemist investigates the trend in reactivity of the group 2 metals or elements by adding each one to separate samples of dilute hydrochloric acid. So you're told in bullet point form what you're supposed to do. So because there's 3 bullet points, I'm going to put 3 sections in my answer, which would kind of make sense if you think about it, because you've got 6 marks to get, so each one would maybe get you 2 marks. What we've automatically now done is turned a 6-mark question to 3 short 2-mark questions. So the first thing that happens is that you get effervescence plus the metal dissolves when you add magnesium to dilute HCl. Now the trend you'd see is that the reactivity increases as you go down the group. Now there's quite a few things you could say to explain this, so I'm going to move the page down a bit to make some space to do this. So you start by saying that the atomic radius increases. We've already said that the trend is down the group, so you don't have to repeat that. This means less nuclear attraction of the outer electrons. So there's less energy needed to remove the outer 2 electrons during that reaction. So that takes us to the end of this clip. Hopefully these 3 questions have been fairly useful to go through. So until next time, thanks for listening and see you soon.